And with that, it's time to kick off today's keynote presentation. I am very honored to have Mr. Craig McLuckie. He is the CEO of Heptio and the co-creator of Kubernetes. Craig, are you with us?
I am indeed. Hey, folks. Thanks so much for tuning in and listening into this webcast. So by way of introduction, I've had an interesting history in building IT technologies. I started my career in enterprise software back at Microsoft, and then spent a fair amount of time at Google, where Joe and I did two interesting things. The first was we built Google Compute Engine, which is a infrastructure as a service offering hosted by Google. That was a fun exercise of bringing relatively traditional enterprise sensibilities to the cloud-native environment that is the Google data center. And then we started the Kubernetes project a little while later, which was sort of flowing technology in the opposite direction, really starting to think about how to bring more progressive ways of thinking about application development and operationalization to traditional data centers. And what I'd like to talk today a little bit about is this idea of cloud-native technologies and how it relates to containers, orchestrators like Kubernetes, microservices, and then hopefully provide a little bit of context for folks that are early in this journey and are really just getting kicked off on how to think about these technologies and where to really start that process. So the interesting thing to see right now is there's obviously two things that are happening concurrently. And at any point in time when you have multiple disruptive trends converging, it creates a very interesting time indeed for enterprise IT professionals. And the two things that I think almost everyone is talking about, obviously, cloud computing is progressing at an unbelievable rate. The rate of growth and the quality of service being delivered by the Amazons, Microsofts, Googles, these hyperscale cloud providers is tremendous. But at the same time, we're starting to see the emergence of this new trend. It's sort of in that peak buzzword phase right now, which is cloud-native technologies. And the thing I'd like you to sort of really think about as you sort of listen to this presentation and walk through this content with me is the idea that these two things aren't the same. At the end of the day, cloud-native technologies, to me at least, represent a pattern of building and running systems, whether they're distributed systems, line of business systems, or any other type of enterprise solution, using a patterns of operating practices that were really pioneered by the internet giants. So if you look back a little ways and you look at the way that companies like Google, Facebook, Twitter operated their businesses, they all had a pretty common thematic element. They were using an approach to delivering software into these massive hyperscale data centers that were pretty consistent. We've seen technologies spun off from these patterns, like all the container technologies were germinated there. The orchestrated technologies like Kubernetes or Mesos were germinated there. And the really exciting thing is that we're moving into a time where those patterns and practices are now becoming accessible to mainstream enterprise providers. They were co-evolved in these internet companies to solve the problems of hyperscale. And a lot of you are probably wondering, like, well, how does this apply to me? I don't necessarily have hyperscale problems right now. And there's an interesting thing across two lines. The first is that many traditional companies are indeed starting to have to deal with some of the problems that the internet companies solve, as IoT is becoming a real driver in industry, as we're starting to see things like traditional enterprises become much more customer focused, creating far higher connectivity to a pretty broad array of consumer customers out there. They are starting to have to deal with some of the challenges that the enterprises, that the internet companies started. But the interesting thing is that these patterns and practices that were pioneered in the internet companies by these cloud-native companies apply very well to solving the problems that enterprise face, not so much around scale, but around the massive heterogeneity of the environments that they're operating in. And so, to me, when I look at the cloud-native technologies that are emerging, and as I start to see enterprises, bringing them into their IT operating environments, there are three key things that create lines of value for consumers of these technologies. The first, and by far in my mind at least, the dominant factor is the idea of productivity. As we see organizations make a transition from using relatively traditional systems where infrastructure provisioning is at the other end of an API call, where everything is very human intensive, where they're applying traditional sysadmin or even DevOps processes, and they move towards this cloud-native operating model. They see significant step functions in terms of individual developer productivity, integer multiples, more productive teams. In some cases, 100 times reduction in time it takes to go from code to production. And then productivity for organizations where the developer is the key asset is becoming increasingly important over time. The second thing that's starting to really show strong around cloud-native technologies is the need for portability. Few organizations today, or sort of sophisticated enterprise organizations today, can settle for one operating environment. They tend to look at an existing set of assets that they have, which are their data centers, and they want to be able to continue to use them. But they also want the option to be able to use the cloud provider delivered resources that have those wonderful elasticity properties that are available on demand. And so a platform that enables organizations to have their developers focus on one environment potentially for dev testing, but then go into production in another environment that they potentially have more control over is extremely exciting. And then the third factor that we start to see with organizations making this transition from traditional VM-based practices to these more progressive cloud-native processes is the efficiency gains that they get. Now, amongst our customers, we see at the low end people reporting around 20% productivity gains as they make the transition to these technologies I'm going to get into more detail around. At the high end, we see up to 80% improvements of resource efficiency. So across those three lines, there's a tremendous amount of opportunity with the cloud-native suite of technologies. So what I'd like to do now is start to distill that down into its constituent pieces. From my perspective, I think there's three essential attributes that really define what cloud-native computing is. The first of it is the idea that you're deploying into Linux application containers. So as we sort of walk this journey, we've seen technologies like Docker really step to the fore. And containers are one of the mainstream pieces of cloud-native computing. The second thing that we've seen is the emergence of orchestration technologies like Kubernetes. And then the other thing that people are really starting to talk about is microservices, how to start to tease applications apart into smaller, more manageable units. And so what I'm going to do now is just dig into those a little bit and provide a little bit more context on what they are, what they mean, and how you might be thinking about them if you're new to this ecosystem. So for many people, the journey towards cloud-native computing starts with containers. And in many folks' minds, that is really synonymous with the Docker technology set. Now, containers aren't new. If you look back through history, folks have been using containers in a variety of different forms for quite some time. And what they were really looking for there was a predictable atom of deployment, the ability to take a bunch of code, package it up with all its dependencies, and then run it in a resource-isolated environment. In fact, if you look into the sort of Wayback Machine, a lot of the origins of modern Linux application containers can be traced back to the cloud provider's use of containers to solve the problems of deploying into environments efficiently. Interestingly enough, Docker originally was built on a stack, which you can trace it down to LXC, which is a Linux native container technologies. If you look below the covers of that, there's a technology called namespace. If you look below that, there's a technology called C groups. And C groups was originally written by Google for exactly this purpose. So the thing that's changed, though, with Docker is that it created an incredibly usable implementation of these container technologies. It enables organizations to take their application, take a baseline package, add a few pieces to it, package it up, and deploy it. And that gives you this incredibly predictable deployment model. So rather than running traditional software configuration management systems in production, you're able to effectively binary copy across everything you need in this beautiful hermetically sealed environment and run it. The other thing that Docker really got right was the idea that the containers themselves look like, and they are an intrinsically portable framework. Their only dependency is on the sort of underlying Linux kernel, and the kernel interfaces are fantastically stable. So you're able to take a Docker container and run it not just on a variety of different environments, you're also able to run it on a variety of different Linux flavors. And the promise of this is huge. As we saw the origins of virtual machine-based technologies, there was the opportunity to establish a VM image and a VM environment as a sort of standard for both on-prem and cloud, but that never really happened. What we're seeing with Docker and the sort of emerging Linux application container technologies that are sort of burgeoning out of that ecosystem is that you have this legitimately portable deployment artifact, which is hugely powerful. The other thing that Docker has done really well is creating this incredibly simple story around crafting, deploying, and managing containers. And the developer experience is really good. Now, the interesting thing is that the way that Docker started to evolve was really around the idea that a container could displace a virtual machine. But when you start to really dig into the potential of containers from this cloud-native perspective, there's a whole lot more that can be done with it if they're used correctly, which leads us to the next part of the journey, which is orchestration technologies. So containers solve the problem of taking a piece of code, packaging it up, and deploying it into an environment. So you can take your code, all of its dependencies, and get it out there. But what it doesn't necessarily solve is how you connect that to other containers. The reality is when you start to build real-world solutions, you need to start thinking about the orchestration. You need to start wiring them together, and you need to think about the long-term management of it. And so we built Kubernetes as a technology to solve this problem. And what we start to see as organizations make this transition to consuming Kubernetes is, first and foremost, they get far higher physical efficiencies out of their environment. So the sort of bin packing capabilities of Kubernetes are huge. We see traditional enterprise organizations running somewhere in the 5 to 7% fleet utilization from a CPU perspective, and then by being able to sort of intelligently mix together workloads onto a common set of machines, they get much, much better utilization than that. The other piece of this is you get much higher levels of developer efficiency. So Kubernetes creates this fantastically operational, sort of operationally viable environment. Developers no longer have to futz with software configuration management technologies. They can rely on some of the best properties of Docker, but then have this fantastically stable environment into which to deploy the technologies, wire them together, and use them. And as a result, organizations themselves become more efficient. You're able to start to craft specialized operations functions that create these curated environments that exist in multiple clouds, deliver them to the development team as a service, and move the needle from a world where your infrastructure provisioning is on the back end of a Jira ticket to a world where everything's API-driven and works far more efficiently. The other thing that I don't think organizations have really got their head around yet, but it is very powerful, is the level of visibility and intrinsic auditability that comes from these technologies. Containers are just running at a high level of abstraction. You have a highly sort of reliable and predictable deployment atom that you can use. And as a result of that, the line of sight you can get into running workloads becomes considerable, and the level of control that you have over those deployment environments are fantastic. So let's jump in and look a little bit at microservices. Now, again, as with Linux application containers, this isn't new. I mean, we've been talking about microservices architectures since the SOA days. And when you start thinking about the utility of this, it's really about being able to take a relatively monolithic application that has to be maintained as a single atom and being able to chew it apart into smaller pieces that can be then assigned to different organizations. And to me, this is as much about being able to scale the team as it is about being able to scale, the application itself. So by being able to create a set of stable interfaces, you get high levels of reuse, you can create specialization in the organization, and you also start to get far higher levels of control and observability as you start to understand the intrinsic dependencies that exist between things. Now, again, the interesting thing is this is not new. Organizations have looked at and tried to construct microservices-based solutions for quite some time. So, if you look at like the days of SOAP and WSDL, there was just a lot of interest in this. But the problem was that the underlying technologies, the mechanisms you really need to support the proliferation and management of a sort of widely scaled set of microservices just didn't exist. And so the interesting thing that we're starting to see now is with the advent of Linux application containers and technologies like Kubernetes, the emergence of this becomes practical for a lot of organizations. So let's take a moment to, I'm going to sort of step back into the Kubernetes space, since obviously that's an area that's near and dear to my heart. And I'll provide a sort of general description of what Kubernetes is for folks that have not had any operating experience with this technology so far. The idea behind Kubernetes is that you're able to take a large number of commodity machines and stitch them together. A lot of people start to think of this as almost like, it's like a virtual mainframe. And I don't want to get tethered to that description because this isn't a proprietary technology. It is a fantastically consistent sort of open source project where you can create these environments that run everywhere. But it has a lot of the favorable properties in that you're able to hide away the complexity, the challenges associated with any individual piece of hardware failing. And what we've tried to do is construct what I consider the sort of Goldilocks abstraction. So it's low enough level that you can run pretty much anything, but it's high enough level that it abstracts you away from the specifics of your infrastructure environment. So it's really that sort of sweet spot that exists between infrastructure as a service and platform as a service. And the nice thing about Kubernetes is that it really is emerging as a standard for distributed systems development. It works pretty much anywhere. So we see organizations creating Kubernetes clusters at the network edge. We see organizations building them on their own infrastructure in their own data centers. We see them using it in the public cloud. And it's really pulled together the ability to create this fantastically consistent experience that runs everywhere. And one of the really nice things about it is that it provides a way to offload a lot of the operational burden onto a smart system. So the mechanics of updating an application become a lot easier. And the analogy I like to use here is that there's just some things that machines do better than people. And one of those is observing a piece of running code, making sure that it's healthy, making scaling decisions about it, making sure that it's appropriately wired into the adjacent systems. And so it's really taking a lot of the traditional emphasis associated with operations and moving it into this domain. Now, the interesting thing that, if you start to kind of like dig into Kubernetes a little bit, it is a technology that it sounds really fancy, and when you start sort of encountering it and digging into it, there's a lot of different pieces that you sort of you need to learn. So there's pods and services and replication controllers, and it takes a while to get your head around it. Once you really dig in, it all makes sense. But at the end of the day, what Kubernetes really is a pretty simple system. There's a database, a distributed database called etcd. That maintains your intended state for what you want to run. So you say, hey, I want 4 of these things, or I want 2 of these things, and I want them wired in this way. And that gets written into this distributed database. And then the rest of Kubernetes is just a set of controllers that look at taking that intrinsic state, which is an expression of the operator's intent, and materializing it on the real world in a way that is using a lot of modern control sort of theory and control approaches. And this enables you to effectively instantiate a set of Linux containers in a group. We believe in the idea that containers are best when used together. The composability, not just in terms of the layers inside a container, but being able to stitch together a number of different containers in a shared resource group is an incredibly powerful pattern. And then Kubernetes makes it really easy to wire in the network and storage assets that you need to connect to these containers together. So as a result of that, you now have an environment where you can say, run this, make sure it's adhering to these policies, make sure it has access to this amount of resource, and just keep it running. And that's what Kubernetes does really well. The other thing that's really nice is that the control metaphor is layered, and so it becomes possible to do much more intrinsically efficient resource management, and it enables you to start dealing with a lot of the sort of the operational complexities of running real-world applications. So the ability to do blue-green deployments, the ability to update an application without experiencing any intrinsic downtime just becomes a natural part of the platform. And so as you start your journey, one of the key things that I encourage you to start thinking about is how you want to consume this technology. And one of the incredible powerful things about Kubernetes, I think the reason that it's really surged ahead in its popularity and its acceptance in the ecosystem is the nature of the community. It's a truly open and welcoming community. It's not owned by any discrete vendor. This is a technology that has really grown up over time through the support and engagement of the community. And so the key decision that you'll have to make as you start thinking about this is, do you want to consume an upstream distribution? Do you have the organizational skills that you need to do that? There's some advantages to that because it is a very fast-moving ecosystem. Despite the amount of hype and awareness around this technology, it's important to recognize that it was only 4 years ago that Brendan Burns and I stood up at DockerCon and announced the existence of it. So it's still in its nascency and it's still emerging pretty quickly. So a lot of really important work is being done upstream, and you probably want to be pretty close to that. On the flip side, there's a lot of value in having a provider representing your interests and needs to the community, making sure that if you encounter a problem, you have an opportunity to have that addressed, and as your needs are being captured and cataloged, there's a vendor that can kind of represent them to the community. And so for us at Heptio, we tend to think that the sort of ideal model for a lot of organizations is being able to move to a model of operating where you're closer to self-reliance with open source, where you have the option to run it yourself if the cost economics make sense. But for a lot of companies, you also need a vendor that can provide that distribution experience to make sure that, as you're trying to get it deployed, as you're trying to get it operated, as you're trying to upgrade it, you can get a little bit of help. So that's where Heptio fits into the mix. And we see ourselves as creating value across these sort of three key lines. One is helping organizations, get as close to that incredibly healthy, burgeoning Kubernetes ecosystem and all of the adjacent technologies around it, not just Kubernetes, but all of these cloud-native technologies, and making sure that it runs pretty much anywhere. So multiple clouds, whether that's Amazon, Microsoft, Google, bare metal, on VMware, any way you want it to work. We are focused on making sure that experience is good. We believe that it's not just about Kubernetes, it's about how you use it. And the biggest problems that organizations we see in the space facing are not just about, how do I deploy Kubernetes? Like, sure, there are some operational complexities associated with doing the basic deployment. It's how do I operate it over time? How do I restructure my teams to make best use of it? Like, how do I get the most value out of this cloud-native transition? And that's something that we've been priding ourselves on doing and driving in the ecosystem. And then, over time, this just needs to fade into the background. It's one of the kind of consistent themes that I think we talk about and a lot of folks inside the community talk about is Kubernetes should be boring. You should be spending your time focused on, how to construct your applications and serve your business. You shouldn't have to worry about the mechanics of the platform. You shouldn't have to worry about the sort of operability of the platform. And so, we personally put a tremendous amount of time into just driving the basic operationalization of Kubernetes, making it easy to deploy upstream with upstream-based technologies. And so our product offering is a technology we call the Heptio Kubernetes subscription. And if you want to get hold of us, you can reach us. You can tweet at us at heptio.com or connect to me directly. There's my email. I'm putting it out there. It's kind of crazy, but feel free to reach out, and I'd be happy to connect you with the organization, and we'll take it from there. So thank you so much for your time.